Hello everybody and welcome to part 2 of solving 100 of the hardest GMAT problems. This section focuses on the data sufficiency problems for geometry type questions. All the timestamps for each of the problems are going to be in the description, so feel free to click around and solve the problems that best fit your needs. While you're clicking around, be sure to hit that like button and hit that subscribe button. It truly means a ton. And with all of that said, let's just dive right into the video. In triangle ABC, point X is the midpoint of AC, Y is the midpoint of BC, R is the midpoint of XC, S is the midpoint of YC. So what is the area of the triangular region RCS? All right, so let's quickly draw out a triangle. Let's see exactly what we have going on here. Here we have some triangle, ABC, and we have a lot of midpoints mentioned, and then we have midpoints of midpoints mentioned. We're told that the midpoint of AC is X, the midpoint of BC is Y, and then we're told the midpoint of XC, so right here, would be point R, and we're told that the midpoint of YC, so right here, would be point S. And then we are asked about the area of triangle RSC. So is there anything we already know about triangle RSC? Well, we should know that it is a similar triangle to triangle ABC. All right, it's a similar triangle such that its side lengths are 1/4 of the size of triangle ABC. So let's write that down. So we know that side length RC, it would take 4 of them to equate to the length of side AC. Similarly, we can say that 4 times the length of SC would equate to the length of BC. And lastly, we could say 4 times the length of RS, oops, I wrote RC, RS would equate to AB. And we know this just because we're told X is the midpoint of AC and then R is the midpoint of XC. So RC must be 4 times smaller than AC, etc., etc. Okay? So what's the first statement tell us? The first statement tells us that the area of triangular region ABX is 32. So here let's look at triangle ABX. Here we have triangle ABX, and we know that its area, we know that this area here is equal to 32. And how would we find this area? Well, we have side length AB times some height, and that would give us 32, such that this dotted line here equates to our height. All right, so let's notice that, again, this height here is going to be half of the total height. If we went from our full height would be 2 of these heights. Therefore, this height here is going to be what? Well, in terms of the height given of this little h, it's going to be half of that distance. Okay? So we would know this height. It would be h over 2. And we know already that RS is 1/4 of AB. And so could we find the area of this triangle given the area of ABX? Well, yes, we absolutely could, because again, we know that RS is 4 times smaller. So if we have AB times H is equal to 32, well, RS is just AB over 4, and then our new height is just some height over 2. We know already that AB times height is 32, so this is going to equal 32 over 8, which is 4. So using statement 1, we can determine the area of our triangle. So statement 1 is valid. Let's look at statement 2. The length of one of the altitudes of triangle ABC is 8. All right, so let's clean this up just a tiny bit, and let's think about this part of the problem. If we're given one of the altitudes, could we determine anything? Well, we could say BX is an altitude with AC being the base, or we could say that this line here is an altitude, or thirdly, this line here could be an altitude. And all of these could be 8. So we don't really have enough information here to determine the area just from the given altitude. We don't have any side links given other than that. So we don't have enough information for statement 2. Therefore, our answer is going to be answer choice A. Statement 1 alone is enough, is sufficient. In the xy plane, region R consists of all of the points xy such that 2x plus 3y is less than or equal to 6. Is the point RS in region R? Okay, so let's draw a little coordinate plane here. So now we have a coordinate plane, and let's graph our function. So we're told that 2x plus 3y is less than or equal to 6. Let's put this in y equals mx plus b form. We can do this by moving our 2x to the opposite side, and then we can divide by 3 to have y is less than or equal to negative 2/3 x plus 2. Next, let's graph this. We know our y-intercept is 2, and our slope is negative 2/3. So we'll put a 3 right here, and then graph this line. Okay, since we're told that region R is less than or equal to this line, we're looking for anything that falls in this shaded area. So what's our first statement? We're told that 3R plus 2S is equal to 6. Well, we want to see if we can find a counter example, something that falls outside of this region that fits this requirement, and if we find such example, then we know that this statement is not possible or not sufficient. So I'm just thinking of simple numbers. Let's plug in 0 for R and 3 for S. If we did that, we'd have the coordinate 0, 3, which would be roughly about right here, and we can see that that's outside of region R. So statement alone is not going to be sufficient. Next, let's see that we have the statement R is less than or equal to 3, and S is less than or equal to 2. Here, let's change colors. Well, notice that this little block right here that I'm shading in yellow would meet this requirement of R being less than 3 and Y being less than 2. And since this block is outside of region R, statement 2 is also not sufficient. Therefore, our answer is E. Both statements are not sufficient. Griffin was able to cover the entire floor of a rectangular room using rectangular rugs measuring 5 by 2 feet, so that none of the rugs overlapped. How many rugs did he use? And then statement 1 says that the longer two sides of the room are 12 feet long. Okay, so we have some room such that the longer of the two sides are 12 feet long. So with this information, could we determine how many rugs are used? Well, since none of the rugs overlap, I know that we must divide this 12 feet into, 6 equal parts, such that the width of the rug of the 2 feet will fit nicely. So this could potentially be 2 foot by 5 foot, and we could have 6 rugs. Or maybe this is 10 feet and this is split in half and we actually have 12 rugs. So statement 1 alone is not enough information. Let's look at statement 2. Statement 2 says what? It says the shorter 2 sides of the room are 10 feet long. Okay, if the shorter of the 2 sides are 10 feet long, then what do I have? Well, similarly, I could say that, I could divide this in half, and I would have my 5 foot area rug and my 2 foot and another 5 foot area rug. But I don't know how long this is. So I don't have enough information here to determine how many rugs I'm going to use. Now let's put the two together. If I'm told that the longer side is 12 feet and the shorter side is 10 feet, well then now I do have enough information. I know the dimensions of my room. Therefore, both statements together are enough to solve the problem. So my answer is going to be choice C. A tank is filled with gasoline to a depth of exactly 2 feet. The tank is a cylinder resting horizontally on its side, with the circular ends oriented vertically. The inside of the tank is exactly 6 feet long. What is the volume of the gasoline in the tank? Okay, let's draw this out. So we have some tank that's situated horizontally, and it's a cylinder. And we have gas that's filling up the tank at a depth of 2 feet. So we know that this distance here is 2 feet. Okay. What does statement 1 say? It says the inside of the tank is exactly 4 feet in diameter. So this tells us that we have a diameter of 4 feet. Okay, that's great, because now I know that my radius is 2 feet. So my tank is filled exactly halfway full. And since I know the radius and I know the length of the tank, we were told in the question that the length of the tank is 6 feet, then I will have enough information to determine the volume. What about statement 2? It says the top surface of the gasoline forms a rectangle and has an area of 24 square feet. Okay, so from a top-down view, we're looking at something like this. Again, we already know that the length of our tank is 6, and if the surface is a 24 square foot surface, then that tells me the height must be 4. Okay, again, this does allow me to determine that my radius will be 2, and I will be able to find out the volume of this tank. Therefore, my answer is going to be choice D. Both statements 1 and 2 independently are sufficient. The figure above represents an L-shaped garden. What is the value of K? Statement 1 says the area of the garden is 189 square feet. So how could we determine this area? Well, let's notice that this distance here would be 15 minus K. And similarly, this distance here is also 15 minus K. Therefore, the full area would be 15 squared minus 15 minus K squared. And we know that this equals 189. Here we have one variable, so we would be able to solve for K here. So statement 1 is sufficient. Remember, whenever you're solving these problems, you don't actually have to solve the problem. You just have to determine if you have enough information in order to do so. And here we have one variable, one equation. We would be able to solve this. Statement 2, what is it saying? It says the perimeter of the garden is 60. Well, here, what do we have? Well, we would have 15 plus 15 plus k plus k plus 15 minus k plus another 15 minus k, and we know that this is equal to 60. So if we add up all of our similar terms, we have 60 plus 0k is equal to 60. And so we really just have written down that 60 is equal to 60. All right? So this isn't enough information here. We have a second variable involved. Okay? 15 minus k, we could just as well call this some variable a. And we don't have enough information to determine what k is just from given the perimeter. So our answer for this problem is going to be answer choice A, such that statement 1 alone is sufficient. The figure above represents a circular graph of company H's total expenses broken down by the expenses for each of its 5 divisions. If O is the center of the circle, and if company H's total expenses are 5.4 million, what are the expenses for division R? Okay, statement 1 says x equals 94 degrees. Up here we have an x degrees. So if we know that this is 94 degrees, and we know that this whole circle, the whole circle represents $5.4 million, then yes, we would be able to determine the expenses for division R, in that we would just do 94 degrees over 360 times the 5.4 mil, and we would have our answer. What does statement 2 say? It says the total expenses for division S and T are twice as much as the expenses for division R. All right, that's all fine and dandy in that S and T are twice that of R. However, without knowing any other information, we're not going to be able to determine the total expenses for division R. So statement 2 is not sufficient, but statement 1 is, so our answer is going to be answer choice A. Statement 1 alone is sufficient. What is the number of cans that can be packed in a certain carton? Statement 1, the interior volume of this carton is 2304 cubic inches. So, okay, we know the volume of the carton, but we don't know anything about the can, so statement 1 is not enough info. What about statement 2? The exterior of each can is 6 inches high and has a diameter of 4 inches. Okay, so similarly, we know the dimensions of the can now, but we don't know anything about the carton, so statement 2 is not going to be sufficient. Now let's see if we can put them together to solve the problem. Okay, so if we know the volume of our box and we know that the dimensions of our can, do we have enough information then in order to solve the problem? And to answer this question, I like to simplify into something, just something simpler. 2304 is a hard number to use. Let's just think of, let's say we have some cube with dimensions that are 2 by 2 by 2. Here we have a volume of 8. Okay, but what if we draw another shape? What if we have just a long rectangle? We have a long rectangle that are dimensions 8 by 1 by 1. Okay, and we have some prism here. Okay, again, we would have a volume equal to 8, but it's a much different shape. So that's something we need to be thinking about. And with these two different shapes, a different amount of cans would fit in each of the cartons. Therefore, even with the two statements combined, we don't have enough information to solve this problem. So this answer is going to be answer E, not enough information. What we need for this problem are the actual dimensions of our carton. Okay. In the figure above, points A, B, C, D, and E all lie on a line, where point A is on both circles, point B is the center of the smaller circle, point C is the center of the larger circle, D is on the smaller circle, and E is on the larger circle. And then it asks, what is the area of the region inside the larger circle and outside of the smaller circle? All right, so we're looking for this shaded region right here. Inside the larger, outside the smaller. So how could we find this area? Well, of course, we would find it by finding the area of our larger circle and then subtracting the area of our smaller circle. And so I'll call it circle L and circle S for large and small, and this will equal the area in question. Okay, so what information do we need in order to determine these areas? Well, we know that the area is just pi r squared, so we need the pi times the radius of our larger circle, and then we need the radius of our smaller circle. All right, so we are really just looking, we need to be able to determine the radii of both our larger and smaller circles. So what about statement 1? What does it tell us? It tells us that AB is 3. Oh, that's fantastic. It already tells us the radius of our smaller circle. That's great. And then it says BC is 2. So this distance is 2. Okay, can we determine our radius for our larger circle from this information? Well, if BC is 2, then that means that CD is 1, and if CD is 1, then we know that the length AC is the radius of our larger circle, and that is a distance of 5. So yes, we're able to determine both of our radius, so statement 1 is sufficient. Now let's look at statement 2. Statement 2, here, let me clear this up just so we have something new to look at. Statement 2 tells us what? It tells us that CD, this small distance here, has a value of 1, and DE has a value of 4. Well, again, fantastic, because C to E is our full larger circle's radius, and so 4 plus 1 is 5. So again, we know that the radius of our larger circle is 5. Now let's see if we have enough information to determine the radius of our smaller circle. So if we already know our larger circle's radius, then we know that A to C must also be 5. And we know the diameter of our smaller circle, because AC is 5 and CD is 1. So the full diameter of our smaller circle is 6. Therefore, the radius is 3. So both statements are enough on their own. So our answer is option D. Both statements alone are sufficient. Line L lies in the xy plane and does not pass through the origin. What is the slope of line L? Okay, let's draw some coordinate plane. Here we go, and let's put in some marks for it. All right, 1, 2, 3, 4. So what are some options for our line? Well, in statement 1, we're told that the x-intercept of line L is twice the y-intercept. So if our x-intercept was 4, then our y-intercept would be 2. Or what if we had some negative values? What if our x-intercept was -2, then our y-intercept would be -1, as again, twice the y-intercept is our x-intercept. So let's draw in these lines. Let's see what we have here. Okay, here we can see that these lines, now picture's not drawn to scale, but they look pretty parallel. What are our slopes? Well, we have a rise of 2 and a run of 4, and our slope is negative, so we have -2/4, which is just -1/2. And down here at the bottom, we have rise 1, run 2, rise over run is again -1/2. So we have the same slope for both cases we tried. So it looks like statement 1 is sufficient with a slope of -1/2. What does statement 2 say? It says the x and y intercepts of the line are both positive. So this is not enough information to tell us much of anything. We could have some line here. Here, let's just draw in a line. We could have some line here or some line here. These are obviously different slopes. So statement 2 is not sufficient. So our answer is going to be option A, where statement 1 alone is sufficient to answer the question. In the figure above, PQR and STU are identical equilateral triangles, and PQ is equal to 6. What is the perimeter of polygon PQWTUVR? So we're looking for this perimeter, which I'm outlining now, PQWTUVR, and we want to find it. Statement 1 tells us that triangle SWV has a perimeter of 9. So this triangle here has a perimeter of 9. We'll notice that everything highlighted, green and yellow would have what length? It wouldn't exactly be a perimeter as there's some overlap, but it would have a length of 36, as we're told that PQ has a length of 6, and we have two congruent equilateral triangles, and 6 times 6 is 36. So if we're just looking for our green perimeter, then we can take 36 and subtract what the perimeter is of our yellow triangle, SWV. We're told it is 9 in statement 1, and we can find the perimeter of our green outline to be 27. So statement 1 is sufficient. What about statement 2? Statement 2 says VW has a length of 3.5. Okay, if VW has a length of 3.5, that is enough info to tell me what QW is and what VR is. However, it doesn't give me any insight into what SV is or what SW is. Therefore, statement 2 is not sufficient to answer the question. So our answer here is just going to be answer choice A. Statement 1 alone is sufficient to answer this question. The hypotenuse of a right triangle is 10 centimeters. What is the perimeter in centimeters of the triangle? Okay, so let's sketch out a right triangle with a hypotenuse of 10. So here we have some right triangle with a hypotenuse of 10, and we want to find the perimeter. So we know that A plus B plus 10 equals our perimeter. So in essence, we really just need to find what is A plus B. If we know what A plus B is, then we are able to determine our perimeter. What is statement 1? Statement 1 says the area of the triangle is 25 square centimeters. So that tells us that A times B divided by 2 is equal to 25, as base times height divided by 2 is the area formula for a triangle. What else do we know? Well, we know that A squared plus B squared is equal to 10 squared or 100 or 100 rather. And could we at all figure out what is a plus b from this information? Now it seems a little bit strange, but let's go off to the side and let's think about what is a plus b squared. Well, a plus b squared would be equal to a squared plus 2 times ab plus b squared. Now let's rearrange this a little bit to have a squared plus b squared plus 2ab. And let's recognize that, well, hey, a squared plus b squared, that's what we have right here. We know that this is 100. And what is 2ab? Well, let's multiply this by 4, both sides here by 4, and we would be left with 2ab is equal to 100. So all in all, what do we have? We have a plus b squared is equal to 200. And that tells me that if I take the square root, then a plus b is equal to the square root of 200. Therefore, statement 1 alone is sufficient, is enough information to answer this question. Now let's look at statement 2. Let's clean this up a bit, give us some extra room to work with. So what do we have here? Statement 2 tells us what? Here, let me rewrite the b. Statement 2 says the two legs of the triangle are of equal length. So instead of b, we kind of just have two a's. And so I can rewrite this perimeter expression as a plus 10 equals p, or 2a plus 10 equals our perimeter. And we really just want to find the value of 2 times a. Well, here, if both legs of the triangle are of equal length, then that implies that we have a 45, 45, 90 right triangle, such that our side length a must be equal to 10 divided by the square root of 2. And if a equals 10 over the square root of 2, then we are able to determine 2a. 2a would just be 2 times 10 over the square root of 2. And what this simplifies to doesn't so much matter as just us understanding that we do have enough information to solve the problem with statement 2 alone. And so our answer for this question is going to be answer D. Both statements 1 and 2 independently are sufficient to answer this question. In the figure above, if the area of triangular region D is 4, what is the length of a side of the square region A? So we want to know this length. We want to know the length of the square region A. What does statement 1 tell us? Well, statement 1 tells us that the area of square region B is 9. So B is a square with area 9, and that means the side length of B would have to be 3, as 3 times 3 is 9. Using this information, we would be able to solve for the side length of square C because we know the area of region D. We know that the side length of square B is 3, and we can multiply it by whatever the side length of C is, and then we would, of course, divide by 2, and we would know that this output must be 4. And so we would be able to solve for C. And then once we have side length C, we could use Pythagorean's theorem to solve for A. So statement 1 is sufficient. Again, we don't have to actually solve for the side length in question. We just need to determine if it's possible. And statement 1 is possible. For statement 2, what do we have? We have the area of square region C is 64 over 9. Well, following the exact same logic, we would be able to determine the side length of C by just taking the square root, and then we could use that value to determine the side length of B, and then use Pythagorean's theorem to find the side length of A. So statement 2 alone is also sufficient, so our answer is choice D. Remember, whenever you're solving these problems, you just have to determine if you are able to find the answer. You don't actually have to find the answer. Next question, what is the value of x plus y in the figure above? Here we're told that W is equal to 95 degrees. So let's put in a 95 here. What does that imply? Well, here's a vertical angle, so this would also be 95 degrees. And then the straight angles, or the angles next to the 95s, would have to be 85 degrees, and this would also have to be 85 degrees. Okay, so here we have these 4 angles, but we don't have enough to determine what x plus y is. What does statement 2 say? It says that Z has an angle measure of 125. All right, so we'll put 125 here. Again, this is a vertical angle, so this would also be 125 degrees. And then this angle here would be 180 degrees minus 125, which is, of course, 55 degrees. And this angle here would also be 55 degrees. So just looking at my blue angles, I only looking at these 4, I again don't have enough information to determine what x plus y is. Now, let's put the 2 statements together. Do I have enough information to determine what x plus y is whenever I put both statements together? Well, this is the information I have. Is there anything else I could figure out? Well, this middle shape enclosed, this is, of course, a quadrilateral. And we know that quadrilaterals have an interior angle measure of 360 degrees. And so why I don't know what these angles are independently, I do know that together, I do know what they would be together, because 85 degrees plus 55 degrees is 140 degrees. And so I know that both of these yellow angles combined must be 360 degrees minus the 140 degrees, leaving me with 120. So I know that these 2 yellow angles combined form an angle measure of 120 degrees. I also know that if I add x plus y, then my output must also equal 360 degrees, because angle x plus this first angle form a straight angle, which would be 180 degrees. And this second yellow angle plus angle y also form a straight angle that would be another 180 degrees. So I know that x plus y plus my 2 yellow angles in question must sum to be 360 degrees. Therefore, with both statements combined, I am able to determine what x plus y is. So the answer for this question is statement C. Both statements combined are sufficient. Fantastic.